My name is Dursun Aydin from Muğla Sıtkı Koçman University. The title of our presentation is Estimating Censored Time-Series Regression Model with Smoothing Spline. Here is outline: Introduction, Censored Time-Series, Nonparametric Time-Series Regression Model, Smoothing Spline, Estimating the Covariance Function, Monte Carlo Simulation Study, Presentation of the result, and discussion. In this section, I will give some information about introduction. The key idea of this study is to model the data time series using smoothing spline. In generally, censored time series data cannot be predicted directly by ordinary method. Here, we tried to overcome this problem. In order to achieve our purpose, we used the imputation method and estimated the covariance function. Finally, made a simulation study to see outcome from the model. If we give some details for censored time series, generally it is expected that time series data will be independent, but most of the time series data are correlated. In here, the key idea to consider time series data but correlated. Basically, there are a number of parametric methods to model and forecast of the time series data, such as ARMA models are defined by the following. In here, Y is the response, rho is the autoregressive parameter, and theta is the moving average parameter, and epsilon is the error term with mean zero and constant variance. As known, ARMA model could be reduced to R and MA model. Such parametric models work reasonable for completely observed time series data, but it is highly possible to accrue some data with irregularities such as detection limit. Usually, the values of our measurement tools have detection limits, and because of that, record the data point as a detection limit instead of true observation. As known, censoring problems arise in different fields, such as business, economics, health, and physical science. The following figures denote the right censored data based on detection limit. In this section, I will give some information about method for censored time series. It's also note that we focused only the right censored time series data. For this purpose, there are two main approaches for solving the censored problems. One is to discard censored observation from dataset, and the second one is treating the censored data as observed points. These approaches will give results, but they are unreliable. To take an account of censored observation, we used imputation method. According to this method, we complete the censored observation with the help of estimated covariance function of time series dataset. And finally, we estimated the covariance function using the nonparametric method based on Nadarwatson kernel estimator. We now define the regression model in our study. The mentioned time series regression model is defined as follows. And here, Y are the observation of the response variable censored from the right by censoring variable. F is the smooth function to be estimated. T is the ordered values time index as known covariate. Epsilon is the uncorrelated random error. And here, to take account of censorship in our regression model, response variable Y should be updated as follows. So, the new right censored regression model could be written as follows. We now explain the smoothing spline method. Our interest is to estimate the function f in the model. To explain the smoothing method, we consider vector form of the regression model is defined as. Our approach to the nonparametric estimation of the vector f is via the minimization penalized least square. Here, K is the positive definite penalty matrix, N is the incidence matrix, Q is the number of unique numbers of variable T. Finally, the elements of the matrix N could be obtained as follows. The first part of the equation given above gives the goodness of fit, while the second part denotes the penalty term. In the previous section, we defined penazite least square. In here, by using it, we obtain a solution to the time series censored data set. The mentioned solution can be obtained with cubic spline and given by. Here, lambda is the smoothing parameter and it is selected with generalized cross-validation. And H lambda is the positive definite head matrix depend on a smoothing parameter. The element of the correlated matrix in F hat can be calculated as. Finally, to measure the quality of the performance of the method, we use the mean square error, which can be computed as. In this section, we give estimation of covariance function. In here, we define a method to obtain a nonparametric autocovariance estimator. This method is easy to apply and free from parametric assumption, and we used this method in our simulation study. The proposed method is based on kernel smoothing estimator and defined as following way. Here, YTS the sample mean, B is the bandwidth parameter, K is the kernel function, and V is the weight function. It's also noted that weights function makes covariance function smaller when H increases. In this section, we made a simulation study. In here, we used 3 sample size and 3 censoring levels, 5%, 15%, 30%, and 1,000 replication is made for each sample size in our study. The response variable in the censored nonparametric model with autocorrelated data is constructed by, where ft is sinus function and t is the ordered values of the time index. Also, it is determined as a correlation value rho equal 0.5 between error terms. As shown in here, the outcomes from the simulation study are summarized in the following figure and table. As can be seen in figure 1, the estimated curve are getting better when the sample size are getting larger and the censoring level is getting lower. In here, as can be seen from the table, the values of the mean square error for the censored model are getting well as sample size larger and censoring level smaller. As for recommendation and discussion, the following expression can be given. As can be seen in figure 1, estimated curves are getting better when the sample size is getting larger and the censoring level is getting lower. When we examine the figure 1 in detail, we can realize that our method estimated the fitted values as if there is no censorship in time series data. It's clear that estimated method really values with using detection limit values. This proves the good quality of our method. In table 1, we found the MSE really small for both sample size and high censoring levels. Thus, from obtained result, it can be said that smoothing spline method works with good performance for nonparametric time series regression model under right censored data. I hope you enjoy listening to me. Thank you.